we're going to just look at the answers to the homework here. So the first one, it says from the numbers in the cloud. And that was actually a big problem for a lot of people because they gave me answers, but not from the numbers in the cloud. So you do have to realize on the test it's going to be very specific, and you also have to read everything quite carefully. So from the numbers in the cloud, write down a square number. And so there are a few answers here. Our first answer is 4. 4 is 2 times 2. So 4 could be an answer, or 16 could be an answer. 16 is 8. 16 is 4 times 4. Okay. Write down a multiple of 7. Once again, from the cloud, so we bring our cloud back up there. And our multiples, we always multiply by, so there's 7 times 1 is 7, 7 times 2 is 14, 7 times 3 is 21, so 21 is going to be our multiple that's in there. I just want you to remember on this first one here, 4 is the answer or 16 is not the answer, but not both. They only want you to write down a square number, so just a single one. And then write down a factor of 30, so we're going to look back up here in the cloud, and our factors, remember, are things that divide into 30. So we know 1 divides into 30, 2 divides into 30, that's 2 times, is 1 times 30, 2 times 15, so already I can see 15 up there. So I'm going to go ahead and write down 15 is my factor of 30. Let's just see if there's any more. 3 times 10, neither of those are in there. And nope, I'm not seeing any other factors. So that's our write down a factor of 30. We've got 15. Okay, let's go on to page 2. And here we go. Here's a list of numbers. And so once again, it's from this list. From the numbers in the list. From the numbers in the list, write down 2 different numbers that add up to an even number. Lots of answers for this, but an even number is a number we can divide by 2. So if you did 5 plus 15, that's an even number, that's 20. Let's see, there's lots of combinations. 30 plus 50 would have worked, that's 80. 60 plus 30, anything that ended in, after you add them up together, that you end up with a 0 on the end, would have worked for this one. Okay, a multiple of 20. So we look up here, our multiples of 20 start at 20. So 20 times 1, not in there. 20 times 2 is 40, not in there. 20 times 3 is 60, and that's our first multiple in there. They also had 100, which is 20 times 5. So you only needed one of those, and you should only write down one of them. Next, a factor of 45. So we're going to look up here again. Our factors divide into it. And there's a few factors. 5 divides into 45. That's 5 times 9. And 15 divides into 45. That's 15 times 3. Either of those work. Okay, let's look. Last one here, a cube number. So we just go up into the list, and I need a number so that that number times itself and times itself again gets me one of these numbers up here. So there's nothing up there. There's no numbers that I can multiply by itself 3 times and get 5, or 15, or 30, or 50, or 60, or 90, or 100. The only one that works here is 5. So 5 cubed, which gets us 125. So 5 cubed is 125. All right. Question 3. Here is a list of numbers. From the list, write down 3 different prime numbers that add together to make 20. So the biggest problem I saw with this one is that sometimes people didn't see that it said prime numbers, and they wrote down something else. So our prime numbers, I'll circle here. 2 is prime, 5 is prime, 7 is prime, 11 is prime, 13 is prime. And 14 and 15 are not prime. So we're not going to circle those. Let's see what's going on with our focus there. All right. So out of those, we just need to find 3 of them that if you add them up together, we get 20. So it's just kind of a trial and error. You start, if you say, with 13, and then add 5 to it, and then add 2 to it. Okay, 13 plus 5 is 18, plus 2 is 20, so that works. Let's see, I also saw, let's see if we do 11 plus 7 is 18, so 11 plus 7 plus 2. I think those are the ones I saw. Okay, it doesn't really matter as long as you use those numbers and get 3 of them to add up to 20. All right, Jan writes down 1 multiple of 9, 2 different factors of 40, and adds her 3 numbers together. The answer is greater than 20, but less than 30. What 3 numbers could Jan have written down? So a lot of choices on this one, but first, our first thing is, look, it's 3 marks here, so they want us to show some work, and there's a lot of that we can get. So first, if we can show some multiples of 9, so we'll start 9 times 1 is 9, 9 times 2 is 18, 9 times 3 is 27, and already we know that our number needs to be greater than, when we add the 3 together, greater than 20 but less than 30. So I'm not going to continue with the multiples of 9 because we're already getting quite big. Then 2 different factors of 40. So I'm just going to write down the factors, and I'm going to use my factor rainbow method. So 1 times 40, 2 times 20. Okay, 3 times can't get 40, so then I'll go 4 times 10, 5 times 8, and then I see that 6 doesn't go into 40. So there are my factors of 40. Now I just need 1 from this first list and 2 from this list. They need to add up to something bigger than 20 but less than 30. And there's loads of combinations that we could make here. For instance, I could do 18 plus 1 plus 2 is going to be 21. That's greater than 20 but less than 30. I could do 9 plus 10 plus 5, and that's going to be 24, which is greater than 20, less than 30. So lots of combinations to get to this last point. So I'm just going to, I'll just leave us with 1. We'll do 18, 1, and 2. But lots of different combinations would have got us there. Question 5. Buses to Acton leave a bus station every 24 minutes. Whoa. Buses to Barton leave the same bus station every 20 minutes. A bus to Acton and a bus to Barton both leave the bus station at 9 a.m. When will a bus to Acton and a bus to Barton next leave the bus station at the same time? Okay, so the very first thing I want to do is I want to make an ordered list. This is a lowest common multiple problem, and they love putting these ones on the exam. So basically what I know, buses to Acton leave the bus station every 24 minutes. So I'm going to write Acton, I'm just going to write A. They leave every 24 minutes. I'll just kind of put a little note there for myself. And from Barton, they leave every 20 minutes. Just kind of a note for myself. The first bus leaves at 9 a.m. from both places. So I'm going to go ahead and just write 9 a.m. down. And then I'm going to go ahead and start trying to figure out what I need to do. Figure out each time the bus is going to leave and when's the next time they're going to leave at the same time. So I'm going to start with Barton, because Barton's very easy. Every 20 minutes. So we know it'll leave at 9, 9:20, 9:40, 10, 10:20. You can see that it's going to just keep repeating itself. 10:40, 11, 11:20. It's just going to keep going on and on and on like this. Okay. Then I'm going to do the same thing for Acton. It leaves every 24 minutes. So 9:24 will be the next time it leaves. Then if I do that again, add 24 minutes, leaves me at 9:48. Add 24 minutes again, and this is where a lot of people came up against their mistake. So if you did this part wrong, then of course you're going to end up with the wrong answer, but you could still end up with marks for work. This is worth 3 marks. So 9:48, and I add in my 24 minutes. And that is going to take me actually to 10:12. Do 24 minutes again. That ends me up at 10:36. 24 minutes again. That ends me up at 11. And I know that I saw 11 on this list. So that is the very first time that they're going to leave the station at the same time again. So I'm going to get 11 a.m. I saw some other people, they did this one in another way. They found the lowest common multiple of 24 and of 20, and the lowest common multiple was 120. So, they may have made a list like this again, but they did 24 and 20, and they just kept adding them up. So 24, 48, so 20, 40, 60, 80, 100. Okay, they kept adding all of them up until they came across the same amount. Okay, so let's see. We add our 24 here. That's going to get us 72. Another 24. So 4, 5, 6. 7, 8, 9. Okay, another 24. 6 and 4 is going to get us 10, and then 9, 10, 11, and then we are carrying another 1, so 12. So they got up to 120, and then they said, okay, 120, and they circled that. And that'll get you some marks, but you need to know how to interpret this. So it's just looking at what on earth, we found the lowest common multiple of 24 and 20, but what are those numbers standing for? So they're standing for minutes, right? They're standing for minutes. So this is 24 minutes, this is 20 minutes, so the lowest common multiple is 120 minutes between the two. And what is 120 minutes? That's 2 hours. So we can have just done 9 a.m. plus 2 hours. That ends us up at 11. Okay? So I think I saw one person use this method and get all the way through and find the right answer. But most of the people who use this method found the right answer. Either method will get you there. Either method will get you some marks because they show that you know what you're doing. But there's a little bit more interpretation involved in keeping this as minutes. You have to realize what is this that you're coming across, and also go back and look at the question. When will a bus to Acton and a bus to Barton next leave the bus station? When is what we're answering. So if I don't answer that with some kind of time, if I answer that with 120 is not a win. And we know we've done something wrong or just left something out. Question 6 is same kind of question, slightly easier because you can find it a little bit quicker. So trams of Piccadilly to Eccles every 9 minutes, and to Didsbury every 12 minutes. A tram to Eccles and a tram to Didsbury both leave Piccadilly at 9 a.m. I know that I'm just saying this absolutely wrong, butchering whatever these are, and I apologize. At what time will a tram to Eccles and a tram to Didsbury Next, leave Piccadilly at the same time. So it's basically exactly the same question. So to Eckley is every 9 minutes. So I write here, once again, 9 minutes. And to Didsbury every 12. We start again. Our beginning time is 9. Both leave at 9 a.m. And then I just kind of go on there. So every 9 minutes, 9, 9:09, 9:18, 9:27. I'm going to try this one a little bit and then see if we're there. And if we're not, we'll just keep going on. So every 12 minutes, 9, 9:12, 9:24, 9. And here's where I saw a lot of people make a mistake. Then they doubled 24 and went to 9:48. But you're adding 12 minutes each time. So then our next time is 9:36. And so I see I haven't got there yet, but I do know that if I add, let's see, another 9 minutes to 27, that will put me at 36. So 9:36 is that time. 9:36 a.m. is the next time that they're both going to meet. One thing I wanted to note, this is not part of the homework, but some people had trouble with the 9s, but you see it makes a pattern. When I am going through my 9s timetable, so I'm adding 9 every time here, it just decreases on, so this is 09, this is 18, this is 27, so this is 9, 8, 7, 6, the next one will be 5, I know that, and then same thing here. As I'm going, this one, 0, 1, 2, 3. The next one will be 4. So that's a kind of neat thing about the 9s. Same thing. This one will be 6. This one will be... No, sorry, this will not be 6. This will be 4. This one will be 5. Okay, so that's a neat thing about the 9s that you might find useful. So both of those questions, not bad. We just need to basically follow kind of the method that you've got, and you will end up at the answer. So here's another one. Here's a list of numbers, and we always have to be careful with that. It's a list of numbers from the list right down, so only from this list. A factor of 24. Our factors are always smaller, so let's even just write out what our factors would be. So a factor of 24 from the list, so not from this list that we've just written out, but we can look up here. 12 happens to be on the list of factors of 24 and up here, and that's the only thing. That's the only thing up there. So we'll just write down 12. A multiple of 7. And our multiples, again, are 7. That's 7 times 1. 7 times 2 is 14. 7 times 3 is 21. 7 times 4 is 28. And we can see that can go on forever and ever and ever. And our list up here only goes up to 20 anyway. So we just find 1, 14, and write that down. So you're just writing down one answer, if there's more than one answer. And it needs to be from the list of numbers up here. And a square number, so just so we can remember, 1 squared is 1, 2 squared is 2 times 2 is 4, 3 squared is 3 times 3 is 9, 4 squared is 4 times 4 is 16. Let's see, are any of those up there so far? So we don't have 1, 4, 9. We do have 16. So 16 is our square number. Okay, the next one is 5 squared is 25. And we can see that's not up there anyway. But you only need one number of the list that satisfies these. Okay, question 8. Here is a list of numbers. From the list, write down a factor of 6. All right, just one factor of 6. There's a few factors of 6 up here. 2 is a factor of 6. 2 times 3. 3 is a factor of 6. 3 times 2. Just write down one of them, but I'll write down for you guys both of them. just 1. All right, a multiple of 6. Okay, so our multiples again, 6 times 1 is 6, 6 times 2 is 12, and we've come across a multiple right there. We can also see that 24 is also a multiple, so just write down one of those. I'll write them both down for you. And Demelza says all prime numbers are odd numbers. Demelza is wrong. Explain why. So all we need to prove that Demelza is wrong is to find one counterexample. So we need to find a prime number that is not odd. And 2 is prime, as it only has factors, one in itself. 1 times 2 is 2, and there's nothing else that makes that combination. So 2 is prime, and lo and behold, and even. So most of the time, they're not asking you to write a huge deal on here. They're just asking you to write something really small. 2 is prime and even. Okay, whew, and we're almost there. We're almost there. So write down the value of the square root of 81. So this symbol, square root, means basically to find the root of this number. So, we know our square numbers. 1 squared is 1, 2 squared is 4, 3 squared is 9. Basically, what it's saying is take this number and find the number that you can multiply by itself. So taking the square root, the symbol here, taking the square root of 81 is the opposite of, or the inverse function of finding a square. Just like we know that addition and subtraction are inverses. Okay, so these are inverse operations. And then we also know that multiplication and division are inverse. And it's the same thing up here. So squaring, I'm just going to use A. Squaring is the inverse of finding the square root. Okay, so if we've got a number and we square it, the inverse or the opposite of doing that is taking that number that you found and finding the square root. So these are also inverses. Anyway, all we need to do is find basically what number times itself equals 81. Okay, so we've got here 1 squared, 2 squared, 3 squared. Just keep writing down our squares. 4 squared, 5 squared. 4 squared is 16. 5 squared is 5 times 5 is 25. 6 squared is 6 times 6 is 36. 7 squared, 7 times 7 is 49. 8 squared, 8 times 8 is 64. 9 squared, 9 times 9 is 81. So we can see if 9 squared is 81, then the square root of 81 must equal 9. Okay, here's the big mistake people have made. Sometimes they write down 9 times 9. No, the answer is just 9. The square root of 81 is 9. 9 squared is 81. So those are inverses to each other, but our answer is just 9. All right, work out the value of 5 squared plus 2 cubed. I actually found a lot of people ended up finding this to be tricky. And I think the big thing is because they know a little bit about indices, and so people started making little mistakes. But here's the deal. If you've got 5 squared and 2 cubed, you know how to evaluate those. So evaluate them. Find out what they actually are. Don't think about rules that you've got for adding indices or multiplying indices. We've actually got 5 squared. We can find out what that is. 5 squared is 5 times 5 is 25. 2 cubed is 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. Okay, so 2 cubed is 8. And now we knew 5 squared is 25. 2 cubed is 8. Let's just add those up. 25 plus 8 equals 33. So our answer is 33. Okay, you just go ahead and you're not going to do any kind of weird stuff. Just actually find out what is 5 squared, what is 2 cubed. They've given us actual numbers, so we're going to use those numbers. All right, work out 50% of 86. So 50% is half. So I'm just going to look at that. This one you can evaluate really by, you could do 86 and then divide it by 2 if you wanted to. But you can really see here, half of 80 is 40, half of 6 is 3. This one worked out really nicely. This was not a mean question. 50% of 86 is 43. All right, half of 86. Work out 3 plus 5 times 2. A lot of people missed this. I think you just forgot BIDMAS. That's our order of operations. So if we look at that, that's brackets first, indices next, then division and multiplication from left to right, and addition and subtraction from left to right. So first I look in here. Is there any division or multiplication? Yes, there is. So I'm going to do that first. 5 times 2 is 10. So we get 3 plus 10. Is there any other division or multiplication? No. Is there addition and subtraction? Yes. 3 plus 10 is 13. So 13 is my answer. Write down an estimate for the square root of 60. So again, a lot of people had trouble with this one. I think I saw a lot of people use a calculator. So it's an estimate. This is a non-calculator question. And it's completely possible. So remembering that square root is the inverse of squaring. Okay, I'm just going to write down what my squares get me again. So 1 squared is 1 times 1 is 1. 2 squared, 2 times 2 is 4. 3 squared, 3 times 3 is 9. 4 squared, 4 times 4 is, 4 squared is 16. 5 squared, 5 times 5 is 25. 6 squared, 6 times 6 is 36. 7 squared, 7 times 7 is 49. 8 squared, 8 times 8 is 64. And I'm going to stop there. And the reason I'm going to stop there is because we're looking for some number times itself that equals 60. And I can see right here that 8 times itself is bigger than 60. Okay? So I know that the square root of 64 is 8. And so I know that it's got to be a smaller number times itself would get me 60. So I know here's the square root of 60. I don't know what it is. But I know that the next lower one down is 7. So the square root of 49, which we can see is lower than the square root of 60, is 7. So I've got right here, this information has basically told me my answer is somewhere between 7 and 8. And I could look at that and get an idea a little bit of if it's going to be closer to 7 or 8, but they actually don't care all that much. They haven't given us a calculator. They're not asking us to work it out. They're just asking us for an estimate. So I can say, hey, that's between 7 and 8, because the square root of 64 is 8, and that's bigger than the square root of 60. The square root of 49 is 7, and that's smaller than the square root of 60, so it's between 7 and 8. So I can write anything between 7.1 to 7.9. Anywhere in between there. So I would just write, I'd be lazy, I'd write 7.5. So that's between 7.1 and 7.9. So I'd just be lazy and I write 7.5, and that's it.